Okay, this is Mr. Viola back with a new unit. Unit 7, Lesson 1. The learning target is I can identify and graph exponential functions by using a table, graph, and or the function. All right, and so the do now is something that we've done in the prior lesson, in the prior unit. So go ahead and try to put it in exponential form first, and then we'll see about getting the actual standard form. So press pause now. Okay, so just a couple of things that you have to be aware of. Every time that you are doing problems like this and they ask you for exponential form, you're going to have to use those laws of exponents, right? The calculator is really not going to help you out much in questions like this because they're open-ended. It could help you out as far as a question goes if it is multiple choice, but these are not multiple choice. So um, let's see. And so when you have back-to-back, I call them back-to-back exponents here. It's like power to a power law. You're multiplying them. So it's 2 times 3. So you have 2 to the 6th power, right? Times 4 to the second. Now, if you wanted exponential form with an exponent, an answer with an exponent, that would be your answer. But if you are going to use your calculator here to get the standard form, all you would have to do is basically put that in to the calculator. All right, so you have 2 to the 6th power, and that's times, press to the right there, and then 4 to the 2nd power, and you press enter, and whoops, see, remember, I had it in exponential form, so I have to get into normal form, normal mode. So just to input that again, and you press enter and you get 1024. And that's basically what you would do as far as that goes. All right, and that would be standard. Right, so let's talk about exponential form first, and then we'll talk about standard form. All right. So 2 to the 4th times 5 to the 4th. Remember what I said in class when we did something like this? Remember, you keep whatever is the same, and the exponents are the same. So what we're going to do is we're going to take the bases and we're going to do 5 times 2, and that is 10. And we're going to keep whatever is the same, so you have 10 to the 4th. Now the bottom is 100 to the 2nd, right? And so I'm just going to put that. So basically what I did here, you really, there's nothing the same, right? So there is nothing the same. So you could just put this into the calculator and you could see that this is going to equal 1, right? But this is the reason why. Like if you were going to just take this number here, right? And you're going to put that in, like as far as an exponent, a base of 10. 100 to the 2nd on the calculator, you can see I have 10,000, right? And then 10 to the 4th is also 10,000. So it's 10,000. What it becomes in standard form is 10,000 over 10,000, and that equals 1. So, so really 100 to the 2nd is 10,000, and 10 to the 4th is 10,000. So if you were actually putting this in standard form, in exponential form, it would be 10 to the 4th times over 10 to the 4th. And if you subtract the exponents, that becomes 10 to the 0 power, which equals 1. And basically, because 10 to the 4th, if you do 10 to the 4th, remember, you do alpha x, and you get the fraction. If you do 10 to the 4th power over 100 to the 2nd power, which is the same number, it's 10,000 over 10,000, you press and it's 1. So that that's what the standard form would be, and this is what the exponential form would be. All right, and now, so for this one, this is pretty straightforward. So it's 3 to the 4th divided by 3 to the 7th. Remember, 4 minus 7. 4 minus 7 is 3. You keep whatever's the same to the negative third. And remember, 3 to the negative third, you flip, right? You're going to put a 1 underneath, flip it, and when you do flip it, it becomes a positive exponent. And it will become 1 over 27. And again, you could put that into the calculator. 3 times 3 is 9, times 3 is 27. So basically, that's your answer in standard form. Right? And let's just do this one. This one, I love this one, but you know, 1 to the 2nd to the 5th. You remember back-to-back exponents, you multiply them. This is 1 to the 10th power times pi to the 0 power. Anything to the 0 power is 1. 1 to the 10th power is 1. Anything to 0 power is 1. So the answer is 1. All right, and that's about it. Get this out of here and going on to the next page, I think. All right, so going to this lesson here, we have exponential functions. And exponential functions are, an exponential function is in the form of y equals a times b to the x power. And I have it right here, right? That's an exponential function, where a is a non-zero constant and b has to be greater than 0. And also b cannot equal 1. All right, x is a real number. So what does this mean? Okay, so we're going to explore a couple of the things, and it's not as difficult as I just made it seem. All right, we have examples right here, and the examples are, this is basically an exponential function. This is basically an exponential function. And what I want you to do is I want you to try to graph it with the graphing calculator. So grab your graphing calculator and input this one, and we'll come back. Press pause now. Okay, so now you're back, and hopefully you did this. You pressed Y equals, and you're going to input 0.5 times 2 to the x power. Right, and this is an exponential function. When you press graph, you'll see exactly what it does, what it looks like. Right, if you press second function and graph again, you'll see the table. So this is basically what it matches exactly what the graph is. All right, so if you go back to the graph, you've kind of taken a look at it. And that's it. So press Y again and input that second one in, -2 times 0.5 to the x power, and graph it. All right, so since it's -2 times 0.5 to the x power, that it kind of looks like backwards where it's below the x-axis, and it crosses, just look at it, it crosses at -2. This is the initial value. This one is the initial value. Notice that that blue, the first one that we graphed, that blue crosses at 0.5 on the y-axis. And if you take a look, if you press second function and table, and you take a look at 0, if you go down and you take a look at where 0 is on the x-axis, you'll see that there's 0.5 there as far as the y goes. And then it's 0, -2, like I said, with this initial value as -2. So that's basically what I wanted to show you. And now you know exactly what they look like as far as as exponential functions. Right? So clear that out. And we're going to go down to the next two. So really, basically, all they want you to do here is substitute. And it's very, very easy. You get your calculator and you just input it. So it says evaluate the functions for the given value of x. You can't get an easier problem. All right. So you have -2 times 5 to the x power, and x is 3. They're telling you. So that you're going to substitute that x in, and you're going to substitute the 3 in as x. So you're going to have y equals oh, I don't know what that is. -2 times 5 to the third instead of this x. All right. And all right. So really, when you get to your calculator, you don't have to press y equals, just putting it in -2 and then parenthesis, exactly what it looks like, close parenthesis, the caret button, and then to the third power. You press enter and you get -250. So when you come back, it's y equals -250. That means when x is 3, y equals -250. You actually just found out what a coordinate with that coordinate is when x is. Remember, this is kind of like, it's a function. So you input an x, you're gonna get a y in return. If you graph this, if you graphed it on the graphing calculator and you pressed second table, which is what we're gonna do next, you could get that without even, you can get that -250. So we're gonna do that for this one. And we're gonna put 2 in as this. We're gonna substitute this 2 in. Substitute this 2 in right there. So I'm gonna rewrite it. P to the T equals 250 times 2 to the third to the second, to the third times 2. So really what it becomes times 2 to the 6th power, because 3 times 2 is 6. That's basically it. So you just kind of put that in. 250. I'm not going to graph this one. 250 times 2 to the 6th power. So all you need is the number. So it's 16,000. That's it. And that means, like, if you're going to put this into like in coordinate form, that means when x is 2, when you're substituting 2 in, the y is basically 16,000. And that's it. So we're gonna stop the recording here, and all you have to do, and we're just gonna get you started on that first one. It says practice evaluate y equals 5 to the x. So this is, I'm just gonna put y equals 5 to the x here. And I'm just gonna put y equals, and x is 2, so you're just gonna put 2. So y is 25, because 5 squared is 25. All right, but just grab your calculator for a second, and we're gonna just put, think about this. We're gonna put the y equals, clear that out, clear this out. All right, and just go ahead and put 5 to the x power. Right, and we're gonna graph it. So it looks like that, right? So take a look. This is the domain that they want, for the domain of 2, 3, and 4. So we need the y's for when x is 2, this y is 25. So if you were putting this in coordinate form, it'd be like that, right? And in coordinate form, we don't know yet, right? So instead of inputting every single number in, I'm just going to go second. You can go second function table, and you could go ahead and get those numbers. So I'm going to go down right now, and look, I'm going to go down to 2. It's 25. The y is 25. Then I go down to 3. And what's the y? It's 125. So if we just put it here, y equals 5 to the third power, and this is 125. And then I'm going to go to 4, and I know it's 625. If I wanted 100, all right, if I wanted 100, you could just put it into the calculator, 5 to the 100th power, or you could just kind of use your calculator to go to 100. Now the number would be astronomical, the y would be astronomical, but what I'm saying is that any y that you have, any x that you're given, any input, you can get an output for, because this is a function and you're inputting a number and you're getting an output. Do the same for the rest of the tables, and press pause now. So for this one right here, say like I have y equals, I'm like getting lazy and I don't want to input the 0 and I don't want to input the 6 every single time. I just put this into the y equals. So then I press second function and graph, which will give me the table. So -3, -3 is 0.14, and you can round it. You can put 0, and it by the way, it repeats over and over again. But honestly, if you round it, it'll probably be to the nearest hundredth. So it would be 0.15, right? Then I'm going to go down to 0 in this table, and 0 is when the input is 0, which is the x, the y is 4. It's pretty easy to see. 4 times 1, 3 to the 0 power, anything to the 0 power is 1. That's 4. And then I'm going to go down to 6. You see how you get your answers? And it's 2,916. Or you could input, you could input them separately and, get the answers that way. But, it's up to you. All right, so you have 2 questions here. Please press pause. Do it any way that you want. You want to input them separately? You can input them separately. If not, then you know what, just do what you want. All right, just graph it. And that's it. Press pause now. So I really just put that in, right? 2 to the 2 times 9 to the x power, and I just check it out. Second function table, and it gives you all the answers. When 0 is x, when the input is 0, the y is 2. When the input is 1, the y is 18. When the input is 2, the output is 162. When the input is 3, the output is 1,458. Nice and fast. Do the same thing. Y, right? I'm going to clear this out. So everybody take the calculator, do 1.5. I'll wait. Maybe I won't. Times 2. Caret button to the x. When you press second function table, you're going to get, so you have to get it for a -2. For this one is -2, 0, and 0.5. All right, let's just see what we have here. Second function table. I didn't press second function, so I see the graph. So, okay. So we have -2, which is your x, y. All right, when x is -2, y is 0.375, and I'm copying it from the calculator. Then it's 0, for when x is 0, y is 1.5. Then I have a problem. I have 0.5. Does anybody know how I see that, or I can get that um, on the, because there's no 0.5 here. It goes from 0 to 1. So I'm not sure how to do that. Does anybody know? So say you're on this and you need a 0.5. You need all of a sudden, you need maybe a good to go by 0.5s. All right, you press second function and then table set. And what this is that you see table set right there. It's second function and window, and that will be table set. It'll bring you to the table set screen. It says table start at -3. That's helpful. Like if you want to start at like say negative 1,000, right? You could skip to that instead of pressing the down button or up button like 1,000 times. All right, so you could skip to it. But this one right here says the table will be going by ones. So I'm just going to change that to 0.5. And now the table will go, when I go back to the table, it's going by 0.5s. All right, so 0.5 is 2.12. I'm going to round it to that. All right, and again, please don't think this is the only way to do it. You could do 1.5 times 2 to the negative second power. It'll give you, see how it gives you the same answer? It's 0.375. That's what it is. So don't think that you could do it this way, the way I do it. But I'm just telling you that it's just easier this way, especially when you have to evaluate the function for a number of domains, a number of different domains. And that is basically it. All right, and it says ponder this. So it says as the x values are increasing by 1, what do you notice is happening in all tables? All right. So what's happening? Well, the y value. Let me bring this down. So as the x is increasing by 1, the y value is being multiplied by the constant b. So just take a look. 2 times 9. I'm sorry. Yeah, 2 times 9. 18. All right. So every single time it's being multiplied by this. Right. So that's what we're going to put. The y value are being multiplied by the constant, and the constant is b. The y values are being multiplied by b. All right, so 2 times 9 is 18. 18 times 9 is 162. 162 times 9 is 1,400 and whatever that is. All right, so 1,458. So this is 0.375 right over here. 0.375 times 2 is 1.5. 1.5 times 2. All right, so this is basically the constant y, and it's being multiplied and multiplied and multiplied. All right, and that's basically it. By the way, I made a mistake over here for some reason. All right, very difficult to see this one right here is because of the 0 as the exponent, and so it doesn't work for that. And then it's 0.5, so it doesn't work for that. But if this was, say, if it was 1, this say you had a 1 here, this would be 3, and you notice that 1.5 times 2 is 3. So it doesn't work for when you go to by 0.5s. When it works, but it's half of 3, which is 1.5. All right, so that's basically what it is. All right, I'm sorry to confuse you with that. Don't go go crazy with it. We're just going over how to, read them. So it says, looking at the graphs, what do you notice about the y-intercepts in the equation? Remember, the y-intercept is the non-zero constant being multiplied in the beginning of the equation. So this is the y-intercept. This is the y-intercept. So you're writing down the y-intercept. It's just it's the first number. The y-intercept is the non-zero constant being multiplied in the beginning of the equation. All right. And that's it. Let's go on to the next page. All right. Anytime you want to stop or you want a little bit more time, just go ahead and press pause. Just going to go over a couple here with you. There's a difference between linear and exponential. Linear is a straight line. It's just a line. It's a straight line. Exponential, it has that, it goes like this. Like when we were graphing them, it kind of hovered around, like some of them hover around the x-axis and then kind of go up like that exponentially. So there's a way to tell if it's linear or an exponential function, and you could basically do this. You could figure out the slope twice, but I don't want to figure out the slope twice. I'm just going to do the jumps. So x is increasing by 1 here. So this is basically what I'm doing. That's plus 1, plus 1, plus 1. So now this is plus 2. This is plus 2. This is plus 2. This is linear. This is linear. Y values are increasing by adding 2. Each time. Each time the Y values increase by adding 2. And they're asking for, so when it asks you, let's do the fast finisher, what is the linear equation for this table? Well, the equation y equals mx plus b. That's the basic format there, right? The equation of line. You need the m and you need the b. You know that the b is 2 because that's the y-intercept, and when x is 0, the other number is the y-intercept. But to get the slope, you could just do x1, x2. Just be careful when you label them, y1, y2. So you have y2, which is 4, y1, which is 2, and then x2, which is 1 minus 0. So obviously the slope is 2 over 1, and the slope is 2. So the equation of this line is y equals 2x plus 2. And that's how you would do that. All right, so going to the next one, all right, the next table, which is this one. Taking a look at the x's, they're increasing by 1. So this is basically what I would do right here. Right, so if you increase it by 1, if x is increasing by 1, but you have to see what the y is doing. And the y is not increasing by 1. The y is, let's see, you could say plus 4, right? That's the first thing you would do, and say all of a sudden, wait, it's not plus 4 again, and it's not plus 4 again. That when it doesn't stay consistent to what the x is doing, that means it's exponential, usually. So let's see what happens. 4 times what? Remember, exponential is always like that multiplication. 4 times what equals 8? Well, it's times 2. 8 times what equals 16? Well, that's times 2. 16 times what equals 32? This is exponential. This is exponential. I'm not going to be able to fit it. I know it. Yeah. All right. This is exponential function. Because the y values increase by multiplying by 2. By 2. This thing is so slow. All right. So what is the exponential equation for this table? Well, remember, an exponential equation is y equals a times b to the x power. And you remember what we said that the first number is? The first number is the y-intercept. There it is. 0, 4. All right, so y equals, the a is that y-intercept, that's the initial value, times whatever is being like multiplied, it's going by times 2, times 2, times 2. So it's 2. And then to the x power. I mean, I guess you don't have to put the parentheses, but some people write it like this. So just be aware. Uh-oh, I'm going to run out of room. 4 times 2 to the x. That's really bad. So some people write it like this. Y equals 4 times 2. No dot in the middle for the multiplication to the x. And that's why, like, that's when you would use the parentheses. Go ahead and do the 3 that are on the bottom. And basically just saying if it's linear or exponential, and explain. Oh, I forgot. Press pause now. So here we go. The first one, you're basically saying that's exponential because as the x increases by 1, the y decreases by multiplying by 0.5. Right, that is an exponential function. All right, number 2 is linear because as the x increases by 4, the y decreases each time by 1. All right, it's by subtraction of 1. And number 3, that's exponential because as the x increases by 1, the y is increasing by multiplying by 3. All right, and that's about it. So say they wanted you to basically write the exponential equation for this table. All right, look, the y-intercept is given. It's right here, right? So that's the a, right? So, and then the b is the amount, the number that it's being multiplied by, the y is being multiplied by every single time. So the b is 0.5, 0.5, and the x stays x. Right? That's the exponential equation for it. To skip to number 3, listen, number 2, the linear equation, this is obviously you would have to find the slope here, and you could find the slope, and this would end up being a direct variation. The y-intercept is 0, and you would just put the equation together in y equals mx plus b form. I'm going to skip that because you know how to do that already. Number 3, though, is, remember, exponential equation is always in this format, a times b to the x power. So the a is the y-intercept. So just think about what the y-intercept is. What's the y-intercept? If you said 4, you're correct. Times b, what is it being multiplied by each time? 3. and then to the x power. So that would be the exponential equation. So just quickly, because I'm really running long, this is already 35 minutes and we're not even halfway through the lesson. Go ahead, and as soon as you see this, you have to do table and graph. Basically, what you're going to do is press y equals 2 to the x power, and then press graph. And that's what you have to graph. Right. So if you have, and actually you're not graphing that because what we give you is a positive, it's a quadrant 1 graph. So you're not dealing with any of the negatives. If you press second and table, you could go down to where x is 0, and then just fill in the table. So 0 is 1, 1 is 2, 2 is to the y is 4. When x is 3, the y is 8, and when x is 4, the y is 16. And then all you have to do is actually graph those numbers. So we're going to start with 0, 1. 0, 1 is like, right there. And then we're going to have 1, 2. 1, 2 is right here. And then we're going to go 2, 4. 2, 4 is right here. This is fun. 3, 8. 3, 8 is right here. And then finally 4, 16. 4, 16 is like right up, right up, right up there. So this is an exponential function. So when you go ahead and you do graph it, it kind of curves like this. Like, I'm sure you could basically make it curve better than I. And press that. And this is y equals. You could put this anywhere, but you do have to name that line and put the. Okay. All right. Okay. And that's basically it. Just use your calculator, and this is something that you definitely could do pretty easily with the calculator. So the domain is the measure of all x's. For this, the domain is basically what you're being asked to graph. So what's the domain of your graph? So domain of your graph is 0, because that's the first x, and it goes on to infinity. All right, and actually I just made a mistake. Can you see what my mistake is? I'm going to put my eraser on. Hopefully it works. No, it's not going to work. So anytime you have infinity, you know that it's not a closed circle. It has to go in that direction. You can't. It's not a bracket. Has to go in that direction forever. And a bracket would mean that it would stop at some point, and it does not stop at any point right there. So that would be a parenthesis on that side. So now, what's the range? What's the y? So where does it start? Where does the y start? All right, it starts at 1. All right, but it's a bracket. And then it goes to infinity in parentheses, right? So the next page, you're going to do the same thing. And in the interest of time, go ahead and just go, and graph them using your calculator, and just graph them using the calculator. And that's it. Press pause now. So basically, right there, you're just using your calculator to do this, and that's basically it. All right. This is on the next page too. I must have made a mistake. So we're gonna go to that next page. Let's see if I have it. Yes, I do. I forgot to delete that. And this is an error analysis. Just take a second and to look at it. And just see exactly what they did wrong. Press pause now. So what they did wrong here is just basically right here. You don't do 6 times 0.5. That's kind of like order of operations. So you learn that it's not 3 to the negative second. You do 0.5 times negative 2 first, and then, I'm sorry, 0.5 raised to the negative second power. And then you basically go ahead and you multiply it by 6, just like on the bottom here in red, this correction. You have g of negative 2, the x is negative 2, so you're basically just putting that into there, and then you're putting this negative 2 into there. And you do 6 times 5.5 to the negative second power. All right, so that becomes 6 times 4. 6 times 4 is 24. It's a positive 24, so that was your answer. So this graph below represents a bacteria population Y after X days. And basically you're just taking the table and you're looking at what you're filling in the plus values for the X, and you're figuring out what Y, what's happening with Y. And obviously this is an exponential graph. This is the same as this table, matches that table, and it's going to match this exponential function equation. All right, so go ahead and fill in all of like what's happening. Obviously the x is adding by 1, and what's the when this happens, what is what you fill in the table based on the graph. Just fill in the table based on the graph, and then figure out what is the y is being multiplied by, and then also figure out what the exponential function equation is. Press pause now. So just to lead you along here, obviously the x was adding 1 like every time. That's pretty easy. And the x's were there. So I'm just going to take this. This is 0, 3. I'm going to put 0, 3 here. And then this is 112, and I'm putting 12 here. And I'm putting 248 into the table. 3, 192, and then finally this last one is 4. So it's given, right? But what is happening to the x's, to the y's? It's obviously being multiplied. What is it being multiplied by? And pausing, hopefully you figured it out. 3 times y equals 12. 12 times y equals 48. 48 times all right. If you said 4, hopefully you did say 4. It's being multiplied by 4 each time. All right. The y-intercept of this graph is what? Well, when x is 0, the other number is the y-intercept. So if you said 3, hopefully you did say 3. Press pause now and, well, see if you could fill in the initial value. I put like little hints here, obviously, and you can get that equation easily. I'm going to press pause right now. And we're back. All right, so the initial value is 3. We know that the y-intercept is 3. It's the initial value. The number being multiplied to get to the next y value is 4. Right, it's being multiplied by 4. So that's what the b is. Right, so this is your b. This is your a. All right, and that's it. This is y equals a times b to the x power. And the x is the thing that's changing, all right, because that's the input. So the a is the initial value, that's the y-intercept. The b is what it's being multiplied by to get to the next y value. And that's basically it. Okay, so this might look a little confusing, but let's read the directions. Using the equation from the previous slide, find the population after day 5. We'll do one together. And day 25 and 12 hours. Whoa, that is great. Love it. All right. So let's talk about the function that we had on the page before. The page before, this was the function. If you don't believe me, look back to the page before. We'll go back to the page before, and this was the function. All right, that was the equation. So that's what we have there. We have right here. All right. So this is an example of how much bacteria, what the bacteria population will be after day 10. So all you're doing is substituting the x. Remember, x is the input. That's basically always time. So 10 is the input. So you do 3 times 4 to the 10th power and solve using the calculator, and that's it. There are 3,145,728 bacteria after day 10. We're going to do the same thing for day 5. So I'm just going to start you off and then use your calculator to figure it out. You're only getting day 5, day 25, and then after 12 hours. So I'm just going to rewrite it and substitute the 5 in for the days. All right, press pause and do the rest of the problems now. Okay, so the first one is 3072, and I just put this in. All right, I'm not, so this is 3 times 4 to the x power, and that's what the function was. So what if you put this in and then you go second function table, right? And you go down to 5 days. We have 5 for the x, and you see that the y is 3072. Or you could just input it into the regular screen of the calculator and get the answer. All right. You could also do that. Let me just go back to let me go to 25 on the x. So this t is 25. So the x is 25, right? That's what this is. This is 25 days. So either you could go down 25 times, press down 25 times, or you could just press second function table start, right? So if you start at 25, look what happens. Second function. So it's 3.4 times 10 to the power of 15. So that's basically what it is. And the calculus is telling you that it's just too large. All right, and we're rounding that off because it comes out to 3 point. Let's just go back to the let's clear this graph, clear it, clear this. Just go 3 times 4 to the 25th day, and you can get enter, and that's basically what you get. So if you do it on the graphing way, it rounds it. Sometimes you don't want the round. You don't want it to round, so it's 3.377699721 times 10 to the 15th power. And if you wanted that in standard form, good luck. Whatever. Just move the decimal over 15 to the right and you have standard form. All right? It's a large number. Use scientific notation. So after 12 hours, wow, 12 hours. So what I'm saying here is that if you kind of fall for the trick here, this is the function, right? Y equals 3 times 4 to the x. And x stands for days, right? So you can't put 12 in there. But how many hours in a day? Sometimes it feels longer, like today, and like this lesson. This is 24 hours in a day, right? So 12 hours is a half a day, right? So you're not putting 12 in for x, you're putting 0.5. And it's because it's a half a day. So this is basically what you would get. And I'm going to put the 0.5 there. And I'm just going to put that in to my calculator, which is 3 times 4 to the 0.5. And then press enter. You get 6. Lonely 6. Y6? No, Y equals 6. Okay, and that's basically it. Okay, so let me go here. Remember, the exponential function is a times b to the x. So to write an exponential, write a function that represents the population, let's read number 1. The bacteria population, y, after x days, can be represented by an exponential function whose graph passes through 0, 100, and 1, 200. Okay, so we have to get, if we're going to just do, if we're going to write that, we're going to put this y equals a b to the x. What did we say that a was? Who can I call on? No one, because no one's here. Okay, so what's a? A is the initial value, right? That's the y-intercept, basically. All right, so what is the y-intercept out of those 2 points? Did they give you the y-intercept? They sure do. A is, waiting. Yes, A is 100. All right, but what is the B? Like, what is happening? Remember, B is what's being multiplied to get to the other number. So 100 times what equals 200? Um, Someone, please. All right, yeah, it's times 2. So it's 2 to the x power. And that's basically it. So if it says find the population after 6 days, pause it and see if you can get that answer. Substitute that 6 in and pause now. If you had 6,400, you are correct. Suppose an investment of 10,000 doubles. The investment is 10,000. That's the initial value. So initial value is the y-intercept. Let me put that as a right now. It doubles in value every 13 years. 13 years. How much is the investment worth after 52 years, after 65 years? So just remember, use that formula. Create a new formula and see if you can do it. All right, remember this, by the way, is a keyword, doubles. That's why it's underlined. It doubles in value. To double in value, you have your B right there. The A is 10,000. Go ahead and write that equation. Press pause now. So you might be a little lost with this one. It is a little tricky, but please, hopefully you got that equation. You have y equals 10,000, right? That's the initial investment. It doubles in value, right? Every 13 years. So it's times 2 to the x power. So where it really is tricky, you don't put 13 in as the x, because what happens is basically it's doubling each of the like 13 years it doubles, another 13 years it doubles, another 13 years you get to 30, it doubles, not 30,000, so it becomes 20,000 in 13 years, doubles in value every 13, and then 26 years it doubles from 20,000 to 40,000. Like, you actually figure this out just by chaining it together. But the reason why I divided by 13 is because it doubles every 13 years. So you have, basically, if in 52 years, that's 4 sets of 13. And that's why I'm dividing by 13. And then when I substitute that 4 in, to the 4th power, I get 160,000. Before you freak out, let me just do this by hand. This is what I'm saying, right? So it starts out as a $10,000 investment, right? So after 13 years, it doubles. 13 goes to 20. After another 13, it goes to 40. After another 13, it goes to 80. After another 13, it goes to 160,000. So think about it. 13 plus 13 plus 13 plus 13 is 52. In 52 years, and it doubles every 13 years, it gets to 160,000. And basically what it is here, and that's basically why you have to divide by 13. All right. And if you do the same thing for the 65 years, and actually you could just figure it out right now, another 13 years would be 65. So you know it's 320. That's 32. Okay. Right. This is another 13 years. So all in total, 13 plus 13 plus 13 plus 13 plus 13, that's 65. You could actually do this one by hand, but you would have to take 65 and divide by 13, and you would get 5. And the way it would look here is $10,000 to n to the fifth power. All right, and it would be 320,000. Congratulations, that was a difficult problem, but actually it's easy by hand too. Like you can still figure it out by hand just doing what I did here on the bottom, even though that's not the correct way. Get you the answer. So try that first one, and try the third one, and try the fourth one, and we'll come back and just remember what we did in that last problem. Suppose investment of 500. So this is your A. That's your initial value. That's the Y-intercept. It doubles. So that's times 2. That's the B. Every 15 years, though. So what is it worth after 30? What is it worth after 45? All right, figure it out. Like, I mean, obviously you could figure it out by hand, but let's just see if you could figure it out, the way, like write the equation for the exponential function, and then substitute the right values in. Press pause now. So the first one is the equation. Hopefully you did get the equation. Y equals 500 times 2 to the x, because it doubles, and that's why you're putting that times 2. But it doubles in value every 15 years. So how much is the investment worth after 30 years? Well, after 30 years, every time it doubles, the 500 doubles every 15 years. 30 years with 30 divided by 15 is 2. So it's $2,000. And basically, if you start, now think about it. You start with an initial investment of 500, right? And 15 years goes by. In 15 years, that 500 becomes 1,000. Another 15, that's 30 now. Another 15, that's 2,000. See what I'm saying? So obviously, like, this is what we got here. So you have to show work with this, and then another 15 would be 45. That would be 4,000. And that's what I got here. So it's 45 divided by 15, because each set of 15 basically is when it doubles. And that's what you have. Y equals 4,000 there. Do number 4, press pause now. Just remember, the investment of 2,000 triples in value every 8 years. Go ahead and do it. Press pause now. Okay, so next one, remember, it's just triples in value every 8 years. So you take 24. So what is the investment worth after 24 years? To do 24 divided by 8 is 3. And you substitute that 3 in for x. You get y equals 2,000 times 3 to the third power is $54,000. And then y equals, after 32 years, you do 32 divided by 8, because every set of 8 years is when this thing triples. That's basically it. It's 162,000. Now, I wasn't going to do this one with you, but it is a pretty cool question, and you don't think it will add up to anything, but let's just do it. If someone in your family agrees to this plan, then let them do it. It's pretty good. All right, fast finisher. This one will surprise you. Tatiana's grandfather gave her 1 penny. This is the initial value. When you write 1 penny, the initial value is 0.01. That's 1 penny. So we're going to put that in that format. And then see, he plans to double the amount given her every day. 2 to the x. And x is the amount of days. So estimate how much she will receive from her grandfather after the 12th day. So go ahead, grab your calculator and substitute the 12 in. How much will Tatiana have after the 12th, just the 12th day of doubling. Yes, $40.96. Even though it's not a lot, okay. You know, that's a lot after 12 days. All right, now do it after 1 month. And 1 month, we'll just say 30 days in a month. Even though not all months have 30 days. Okay. So go ahead and substitute in. Use the same formula, same function of y equals 0.01 times 2 to the x. Go ahead and substitute. Press pause now. Yes, that's right. After 30 days, 10,737,418.24. So that's pretty surprising. Remember, the A in this question was 1 penny. Remember, the A is the initial value. Just think of it A. That's the first letter in the alphabet. It's what they start with. The B is how much is being multiplied. So you're basically doubling the amount. If she was tripling the amount, you put 3. But since they're doubling, you put 2. And that's where you're getting the y equals. Remember, y equals A, B to the x. That is the exponential function equation. And that's basically it. Go ahead and see if you can answer this exit slip. And press pause now. All right, so let's just go over this because this is a really good one. The New York Volleyball Association invited 64 teams to compete in a tournament. Right? After each round, half the teams were eliminated. So let's just start with the 64. That is the initial amount of teams. So what did we say? Remember, this is the formula. All right. So 64 is the initial amount. So you definitely have to have, now I'm just using Y, but it's T, right? So let's just say T. The A has to be 64. And all of them are. So you can't even cancel anything out. So half the amount of teams were eliminated each round. So what's the multiplication going to be for half? That's it. Use your answer if you pick D. That's correct. Remember, this is 1.5, so that means you're gaining teams. You don't do that, right? And this is a negative. You're not timesing by negative. Remember, when you basically each round. So if there's 64 teams in the first round, there's 32 in the next. That's 0.5. And then after the second round, half of 32 is 16. So, and you could go on, and then there's 8. Kind of like the college basketball tournament. 0.5, 0.5. That's it. And that's why it's T. All righty. So, before you graph, determine if the function is linear or exponential. Obviously. All right. So, just basically go ahead and press pause now. Just look at the tables, do the loops, and see if you can see if it's linear or exponential. Put it on the top if it's linear, if you think it is. Put it on the top if you think it's exponential, and press pause now. Okay, so here we go. The first table is linear. And it's because it's obviously every y value you're adding 3 as the x increases by 1. And I figured out the slope 7 minus 4 is y2 minus y1 over x2 minus x1, and you get the slope of 3. And you can probably tell that the slope is 3, but I like to check. The y-intercept is 4 because x is 0 and then y is 4. And so the equation is y equals 3x plus 4. Second one, you can tell table B is exponential because every y value is multiplied by 2. All right, so obviously 6 times 2 is 12. 12 times 2 is 24. And the equation, remember, The exponential equation is y equals a times b to the x. Right? So a is the initial value. The initial value is 3 because x is 0, and the other number right there is 3. So that's the initial value. The b is whatever the y value is being multiplied by, and in this case it's 2 to the x power, and that is basically it. That was one long lesson. Yes, an hour and 5 minutes of video here. And we are finished. See you next time.